B2 with the Academy of Science and Technology. A complex function is a function from complex numbers to complex numbers. In other words, if D is a collection of complex numbers, then any function f from D to C is called a complex function. So you can make lot of complex functions like f is z equal to z cube, f is z equal to z square plus 1, f is z equal to sin z plus 1, f is z equal to e raised to z plus z, f is z equal to z cos z plus 3z, etc. Complex analysis, traditionally known as the theory of functions of a complex variable. It has a lot of importance in solving a large number of problems in the field of engineering and science, especially in electrical engineering. It is used in two major areas, signal processing and control theory. In signal processing, complex analysis and Fourier series go hand in hand in the analysis of signals, and this by itself has a lot of applications. For example, in communication systems, that's our broadband, Wi-Fi, satellite communication, image compression and video or audio compression, signal filtering or repair or reconstruction, etc. Basically, applications of signal processing are indirectly applications of complex analysis. In control theory, specifically in the analysis of stability of systems and controller design. I already defined what's a complex function. So you consider a complex function f from D to C. Since it is a function, each element in D has an image in C. You consider an arbitrary element Z in D. So the image of Z under F, that is our f of Z, is an element in C. We know each element in C has a real and imaginary part. So Fz must also have a real and imaginary part. That is, Fz can be expressed in the form u plus iv. And you can see u and v are functions of x and y. That is, they are real functions. I wish to illustrate through few examples that each complex function can be expressed in the form u plus iv. So consider the simple function f is equal to z square. We know the complex variable z is x plus iy. So replace z by x plus iy. So it is x plus iy the whole square, that is x square minus y square plus I into 2xy. See, this is in the form u plus iv. Here u is x square minus y square and v is 2xy. You consider another example. Assume f z is z conjugate, that is x minus iy. See, it is in the form u plus iv. Here u is x and v is. Next, consider a trigonometric function cos z. Let f is equal to cos z, that is cos x plus iy. We can expand cos x plus iy by using the equation for cos alpha plus beta. We know cos alpha plus beta is cos alpha cos beta minus sin alpha sin beta. So this is cos x cos iy minus sin x sin iy. Again we know cos ix is cos hx and the sin ix is I sin hx. So cos x cos hy minus I sin x sin hy. See, this is in the form u plus iv, where u is equal to cos x cos hy and v is minus sin x sin hy. The exponential function, that is f is equal to e raised to z, that is e raised to x plus iy, that is e raised to x into e raised to iy, how can we convert e raised to iy? So for that, you apply Euler's formula. What is Euler's formula? Euler's formula is e raised to I theta is cos theta plus I sin theta. See, this is Euler's formula. So you can see it is cos y plus I sin y. That is e raised to x cos y plus I e raised to x sin y. Now it is in the form u plus iv. Here u is e raised to x cos y and v is e raised to x sin y. See, in this way you can express any complex function in the form u plus iv. But in the case of logarithmic function, it is better to consider z in polar form. So consider fz as log z. Log z is r e raised to I theta. That is log r plus I theta. What is r? R is root x square plus y square and theta is tan inverse y by x. This is in the form u plus iv. Here u is log root x square plus y square and v is tan inverse y by x. So you always keep in your mind any complex function can be expressed in the form u plus iv. Thank you.